Indeed.
Okay. So soapberry bugs and Staphylococcus aureus implicate that natural selection is a process of trial and error rather than a deliberate creation. So basically what I'm trying to say is that they aren't specifically selecting traits to be productive against methicillin and penicillin. It's just by chance and by trial and error that they evolve, and eventually they're going to get to a trait that is so powerful that it really is their one key to survival. So this isn't deliberate. The bacteria weren't like, well, this protein isn't working, so let's go and find another protein that we can use to synthesize our cell wall. It was mutations and just chance, really, that they evolved that to hold that trait, and it has worked really powerful. Natural selection is highly contingent upon the situation present and all the factors, the time, place, that can contribute to survival. So as we saw with soapberry bugs in central and southern Florida, that those two environments demanded different characteristics and different traits for the soapberry bugs to be the most successful at survival. Homology is another piece of evidence towards Darwinian evolution, and it comes with the concept, Darwinian evolution comes with the concept of homology, so this is a really crucial factor to explain evolution. And its definition is a similarity in characteristics resulting from a shared ancestry. So because his idea of divergent evolution, where we all come from a common ancestor and then we go into different, we spread into different species because of different factors, different environments. We have shared traits and shared characteristics with those between a species and the one that we diverged from and the other diverged species, but sometimes they serve a different purpose. This is a picture that's in our book, how it explains how human, cat, whales, and bats all have the same homologous structures, but they serve different functions. In cats, it's for like, what? Oh, gosh. So Clark's going to talk about that too. The theory of homology essentially states that natural selection has altered features that were present in ancestral organisms to yield novel divergent species. The structure of attributes in resultant species is similar, but usually the function of the similar structures is what was modified, typically so as to most sensibly suit the varying environments. Are there any questions? Alright,
so in homology we have two types of homologies. You can have like an anatomical homologies or molecular homologies. And evolution, basically, like Jacqueline says, closely related species should come from some distant ancestor, and they share like similar features, like mammal forelimbs, and like Jacqueline said, homologous structures are variations in a structural theme that's present in a common ancestor. So like in the picture that she just showed, if we look at the human arm, in our arm we have a humerus, an ulna, and a radial bone in our arms.
Yeah,
and
yellow's radius.
Yes.
Are you sure?
yeah.
Yellow is radius.
Yeah, okay, sorry. The humerus, the radius, and the ulna, and then we have carpal bones in our hand. And you can see the similar colors in like a whale, a dolphin fin, or a bird arm, but they all serve different purposes. Like ours would be to lift and carry things, and then birds would be obviously to fly, and then dolphins to swim. So, homologies are normally discovered at like early stages of development, and because they're not really visible in in adults when we get older. And vestigial structures are basically structures that are still like within an organism, but they might not necessarily use. Like humans have a vestigial tail, but in us it's kind of turned into our tailbone. Like at one point it was said that we were supposed to have tails, but we obviously don't anymore. And in this one, okay, hold on, we might have to airplay for because I put a different picture in.
So I'm gonna pause it? Or?
Yeah.